Okay, moving into part 2 for our quadratics in 3 forms lesson. And I just noticed after ending the last video, it's like 16 minutes long. Sheesh, I can ramble on a lot. Oh my gosh. Sorry about that. But hopefully you found that information useful if you've never seen this stuff before. If you have, then you probably skipped that video and went straight here. Okay. So in this video, I'm going to talk about 3 examples. The last video, we talked about standard form, vertex form, and factored form, which I've kindly listed right here. And we're just going to do example 1, 2, and 3 in this video. Each of these examples asks us to write it in one of the 3 forms. And that's what we're going to do. So here we go with example 1. We're going to start off with writing the function in standard form. This is going to be great. So I'll read the problem. It says the parabola created by the quadratic function f, it's like a curly f like this, contains the point 4, 0, 1, 12, and -3, -28. Now the goal is, using these 3 points, write the function f in standard form. So what does this mean? Standard form, say standard form says ax squared, or I should say y equals, I'm going to say y equals ax squared plus bx plus c. Okay? That is standard form for a quadratic function. So we want to find a, b, and c. That's our goal. So I'm going to actually write that. I'll write that in yellow. Goal, find a, b, and c. And the strategy we're going to do to solve this is we're given 3 points, this guy, and this guy. We have 3 unknowns. So if we can somehow maybe use these points to generate 3 equations, if we have 3 equations and 3 unknowns, we can solve that. So let me show you. The first point. So point 1, which is 4, 0. What does this say? Right? X is 4 and y is 0. So in standard form, this says 0 equals a times x squared. So this is 4 squared. I'll use parentheses instead of a dot. Parentheses 4 squared plus b times x is 4 plus c. And notice all I'm doing is I'm taking the point 4, 0 and plugging in this 0 to this y right here, and I'm plugging this 4 up here and here. Notice the c is isolated, it's all alone, so I don't need to plug in an x value there. Okay? All right. So let's go. Point 2 is, what was it? 1, 12. And so point 2 is 1, 12 means y is 12. And then x is 1. So x squared is 1 squared plus b times 1 plus c. Last point, point 3, is -3, -28, which means y is -28 equals a times -3 squared plus b times -3 plus c. Now, let me rewrite these, okay? Maybe I'll do this in red. Rewrite. Well, I don't know if I want to say the word rewrite. I don't like that. What's the word? It's not simplify. It's not really rewrite, I guess. All I'm saying is I'm going to take 4 and actually square it and not leave it so that it's so hideous. I'm basically just going to make this look prettier. 4 squared, this guy. 4 squared is 16. So this is 16a plus 4b plus c equals 0. And the next one is 1a plus 1b plus c equals 12. And the next one is negative 3 squared. What's that? Right? Negative 3 squared. That's like negative 3 times negative 3, which is positive 9. Careful there. Positive 9a minus 3b plus c equals negative 28. And so I erase all that, and I've got a system, right? This is a system of equations. So write a matrix. Write a matrix. And use RREF, row reduced echelon form. If we make our matrix and solve this, then we are done, right? We will find the coefficients A, B, and C. So I'm going to make my matrix. Isn't this wonderful? The fact that Unit 3 has already shown its use to us in a new context. I think that's awesome. And so we've got our augmented matrix there. So now I need to go to this. Hey, look at that. I'm already on the matrix calculator. Nice. And so I'm going to type in these numbers. 16. This was 4. 1. And I think it was 0. And then, oh, man, memory. Hello, memory. Memory? 1, 1, 1, 12. Okay. 1, 1, 1, 12. I forgot again. And 9, negative 3, 1, negative 28. Okay. 9, negative 3. How? Come on. 1 and negative 28. I guess I should have pre-typed this before doing whatever. I don't care. So I'm using Desmos matrix calculator. You can Google this easy by just typing in Desmos matrix and then clicking the link, and there you go. So I made my matrix. I put row reduced echelon form, RREF, and I got, ta-da, my row reduced echelon form. So it says negative 2, 6, and 8. So that's what I'm going to do. I'm going to say my row reduced echelon form gives me 1, 0, 0, negative 2, 0, 1, 0, 6, and 0, 0, 1, 8. Which means A equals negative 2, B equals 6, C equals 8. So let's finalize my answer. I remember the question asked us to write it in standard form. Therefore, use the little 3 dots, meaning therefore, y equals negative 2x squared plus 6x plus 8. And that is my standard form quadratic equation. Ta-da! Isn't that nice? Isn't that awesome? So yeah, this example, I use this to illustrate the idea that if you have, we have 3 unknowns, A, B, C, which means if we can generate 3 equations, we can use a system of equations to solve for A, B, C. And incidentally, you can generate these if you have 3 points. So as long as your parabola contains 3 points, you can use this method to find standard form. Isn't that great? That's just awesome. That's just so wonderful. Okay. And now let's go to example 2. Now, that one took a little bit of time, but I think example 2 and 3 should go by a little bit quicker. So example 2, I'll read this one, says the quadratic function g of x has roots at x equals negative 1 and x equals 4, and the function contains the point 2, 12. So again, notice I'm given 3 points here, kind of, right? I'm given 2 roots, which are x-intercepts, and another point. So let's write g of x in factored form. Well, factored form says y equals a times x minus x1, x minus x2. Oh, sorry. I was calling them r in the video. x minus r1, x minus r2. It doesn't really matter what you call them. They could be x1, x2. They could be r1, r2. It doesn't matter. Okay, so y equals this. Now, I'm given my roots here. The first one is that x equals -1. So my first root, right, r1 equals -1. And the second root, r2, equals 4. So just substitute these in. Y equals a times x minus -1 is x plus 1. And x minus r2 is x minus 4. Nice. Now, the only thing left to find is a. So now, find a. And how can we do that? How can we find a? Well, if you look, there are sort of three unknowns here, y, a, and x. But you have a point, 2, 12. So, if you use this point 2, 12, where 2 is x and 12 is y, then, well, let's just see what happens there. Let's do blue. So, use x, y equals 2, 12. And this generates 12 equals a times 2 plus 1. You know what? Hold up. I want to make this prettier. Now find a. I'm going to do this. I'm going to say, why? I'm going to rewrite it. This is just to be real clear. And use x, y equals 1, 2. Sorry, I had a brain fart there. 2, 12. Okay? So y is 12 and x is 2. So 2 plus 1 and 2 minus 4. There we go. That's nice. That's pretty. So let's do some calculations here. 12 equals a times 2 plus 1 is 3, and 2 minus 4 is -2. Of course, 3 times -2 is -6. So divide both sides by -6. And this leads to the conclusion that a equals -2. Because 12 divided by -6 is -2. And so now, my final answer, right? Therefore, y equals a is -2 times x plus 1 times x minus 4. And we're done. Wasn't that so simple? Not so bad, right? So the idea here is if you're going to write it in factored form and the information you have is you're given the roots and a point, well, you can directly substitute the roots. That gets rid of that. And then you just use the point to find the a value. Yeah, that's it. Okay, now, the challenge I give you, so maybe extension, write g of x in standard form and find 2 distinct ways of solving this problem. Okay, so I'm going to kind of click pause on that, okay? We are going to come back to that in this video, but I'm going to, I think, come back to it at the end, okay? Because it's going to take a minute to discuss, and I just want to hit vertex form real quick. So there it is in factored form. Let's go now to example 3 and get this graph. Or let's write this in vertex form. So context, the graph of h of x has a minimum at -1, -4, and contains the point 2, 3. So minimum is here at -1, -4, and it has the point 2, 3. So, right, so that's kind of a quick visual of what's going on. So let's write this function in vertex form. Hey, hold on a second. Hold on, would you give me just a second? Would you be so kind? I actually want to I need to check my notes. I don't remember if is this the one I want to do? Let me check. I'm observing. Let's see. This is not the question I want to do. I need to make a quick edit, real time, a surgical edit. If you will excuse me for just 1 second, I want to fix this value. I used this example in class, but I don't want to use this as much. I'm so sorry. Oh, so unprofessional of me. You said, Mr. Spake, how could you do this to me? How could you waste my time when I have access to a fast forward button? How could you do this? And then the other point is 5,18. Okay. All right. Sorry, I had 2 examples for vertex form, and I just want to use this one. That's all. I just want to use this one. Okay. We're ready. Same problem, just I tweaked the values a little bit, that's all. Okay? Okay, so let's write the function in vertex form. So vertex form, yikes, that's not form is y equals a times x minus h squared plus k. All right? Now, we know the vertex is the minimum, right? H comma k is the minimum at 3 comma 2. So let's just plug that in, right? This becomes y equals a times x minus 3 squared plus k is 2. Look at that, easy enough, right? Cool. So now how do you find a? Well, you find a the same way you found a in the previous problem. Look, we plugged in the roots, and then we plugged in a point to find a. In this case, we're going to plug in the vertex, h comma k, and then just plug in that other point to find a. So let's switch colors here for just a second. Let's do green. I say, oops, use the point x comma y equals 5 comma 18. This tells us that 18 equals a times, x is 5 minus 3 squared plus 2. Now 5 minus 3 squared, we know that that is 2 squared plus 2. If I subtract 2 from both sides, I get 16. And 2 squared is 4a. So then divide both sides by 4. I get a equals 16 over 4, which is 4. So now that I found a, standard form is, vertex form is, therefore, y equals a is 4 times x minus 3 squared plus 2. And done. And that's it. that's pretty much it. I think factored form and vertex form, if you're just given that information, not so bad, really, not that bad. We'll work harder examples in the future where you have to convert between forms. But for now, if you find that you have this information, notice the information we were given for example 3. I had a vertex and I had a second point. So long as I have that information, I can certainly write vertex form. Okay. Now, example 3 also has an extension, which is to write it in standard form. I am going to save that for the next video because there are 5 methods of doing this so far that I've found. And I will save that for the last video. But to wrap up this video, to wrap up this one, because this is important, and you do need to know this. How do I write, going back to example 2 here, it's the same problem, but suppose instead of saying factored form, it asked, write g of x in standard form. So, how could I do this? How could I write g of x in standard form? And the challenge I was giving you was find at least two distinct ways of solving this problem. So I'm going to do two methods. I'm going to do them in yellow. Method 1. Boop. Oh, I want a nicer underline. Okay. Method 1 is to take vertex form. Or I'm sorry. I was thinking about the last problem. Take factored form. Factored form says y equals negative 2 times x plus 1, x minus 4. If you distribute, I'm going to write that word, distribute. Meaning just multiply this out, well, then you will find standard form. So just observe, right? So in order to distribute, we're gonna save the 2 for last, and we're gonna start with let's do x times x is x squared, and then x times negative 4 is negative 4x, and then 1 times x is plus x, and then let's do green. 1 times negative 4 is negative 4. And notice I used blue there in the middle because this is just x squared minus 3x minus 4, right? And that's that part distributed. But you still have this negative 2 chilling out here. So it's negative 2 times this, negative 2 times this, right? And that's it. I have just distributed. Sometimes we call this FOIL. Some people call it FOIL, which stands for first, outer, inner, last, if you care. First was that first blue one, then the outers, and then the inners. Yeah, okay. I'm not going to explain distribution in this video, sorry. Okay. And so there we go. Let's say therefore y equals, let's distribute that negative 2, right? You're going to distribute that negative 2 here, here, and whoop, here. So that equals negative 2x squared. Negative 2 times negative 3x is positive 6x, and negative 2 times negative 4 is positive 8. And that is your solution. Okay? That is the super quick way to do it because we already found it in factored form. Now, the reason I say, why even bother doing this in multiple forms, right? Why even bother doing a second method is if it didn't have the question to put it in factored form first, you could skip the fact that it says factored form and use a different method to just get straight to standard form. Now remember, in example 1, I'll remind you, in example 1, we had 3 points, 1, 2, 3. And as long as you have 3 points, you can create a matrix to find the coefficients in standard form. Well, hey, if R1 equals negative 1, that means the x-intercept is at negative 1 comma 0. And if R2 is at 4, my roots, then the x-intercept is at 4 comma 0. And then I have the last point at 2 comma 12. So you can create a system, right? You can create a system here. You say, so now I say y equals ax squared plus bx plus c, and you plug in these 3 points to make your system. So I'll do that real quick. I won't spend nearly as much time because we did it in example 1, But if you want to pause the video and check your work, here's what I'm doing. So let's use the first point. Y is 0. A times -1 squared plus B times -1 plus C, which is just A minus B plus C equals 0. And then the next one is 0 equals A times 4 squared plus B times 4 plus C. And that is just 16A plus 4B plus C equals 0. And then the last one is 12 equals A times 2 squared plus B times 2 plus C, which is 4A plus 2B plus C equals 12. There's your system, right? So make your matrix. 1, -1, 1, 0. 16, 4, 1, 0. 4, 2, 1, 12. There's my matrix. So let's go make that in Desmos. Go over here. I believe it was 1, -1, 1, 0. The next one was 16. Whoa, not 46. 16, 4, 1, 0. And then the last one was it 4, 2, 1, and 12? And hey, there you go. There it is. A equals -2, B equals 6, and C equals 8. So you get the same matrix you get. I think it's -2, 6, and 8. Ooh, yikes, that's ugly. Hold on. -2, 6, and 8. Boop. Boop. 1, 0, 0, 0, 1, 0, 0, 0, 1. There's my matrix, which means, therefore, y equals -2x squared plus 6x plus 8. And there you have it, 2 methods. So, yeah. So I show you these 2 methods again. I'm just going to restate it. I already stated it, but I'm just going to say it one last time to hit it home. If the question gave you this information and said write g of x in standard form, did not mention anything about factored form, you could either recognize that you're able to go to factored form because you have the roots and then use the distributive property like in method 1 to find standard form, or you can recognize that those 2 roots are x-intercepts, which are 2 points, and then you have a third point, in which case you can make a system of equations, a matrix, and solve. And that is the beauty of those 2 methods. Yay! Okay. Whew. That was a lot. That was a lot of talking. But there's some nice 3 solid examples. Beautiful work here. And in the next video, which I don't know if I'm actually going to record tonight. In the next video, we're going to talk about 5 methods. So basically, this extension question I've asked here of writing h of x in standard form, well, in the next video, I'm going to do that 5 times. I'm going to show you 5 different methods on how to do that. Okay, but that's enough for this. I'll shut up now. You go enjoy your night or morning or day or whatever it is that you need to go do. And I'll see you around.